Recording. Stop recording. Button.
So all words are made up. Like this word. Tonsillectomy. Y'all know what tonsils are. Everybody's got tonsils. Okay? So tonsil, ecto. Ecto. Now, these scientific words especially use the Latin and Greek roots. So ecto comes from an old Greek word that sounds very similar to exit, our old word exit, out of, to leave, move away from. And then tomy means to cut. So think of your appendectomy. Same thing. So the word tonsillectomy means to cut out of the body. So tonsillectomy is we're going to cut your tonsils out of your body. That's what the word tonsillectomy means. It's got all these roots. So if you know those old ancient, and you can get dictionaries that, like medical dictionaries, or that have a lot of these Latin and Greek roots. They really help language in general. They used to teach Latin. When my grandmother was in high school, when she went through school, she went to a one-room school. She had geometry, algebra, trigonometry, American and British literature, and Latin. In a one-room schoolhouse, there were 6 girls that graduated in her high school class. And then they had their 50th high school class reunion, 100% attendance, including their teacher. Anyway, they have Latin, and Latin comes in handy because everything's like based in Latin. Anyway, so tonsillectomy is exit, to cut the tonsils out. So appendectomy is the same word. Appendix, exit, to cut. Appendectomy, to cut the appendix out. So biology is the same way. That word biology. So I'm a word person. I do a lot of that throughout the semester. It helps me make sense out of words. So biology, everybody, I'm sure y'all have all heard, ology means the study of. So bio is life, or living organisms. So biology is the study of life, or the study of living organisms. Now, from a scientific perspective, rather than trying to set just a set definition for living organisms, what they found it's easier to do is come up with a list of characteristics that living organisms have. All living organisms have these characteristics in common. And one of the first that we're going to put in this list is order. Living organisms have order, like a machine, like a computer. You don't just throw a bunch of pieces, parts into the computer and hope it works. You don't just throw a pile of nuts and bolts and carburetors and batteries and whatnot together and some wheels and steering wheels and some gears and hope that it's a car and drives down the road. It's put together in a specific order. It's got to have order. So a machine, a cell, an organism, a system has to have order in order to function properly. Now, living organisms, biology, we start out, and this is how we're going to run through the semester. We have atoms. So here we've got the periodic table of elements. And this one, that's an old chart. I think it dates from 1993. I looked at it while ago, it's copyright. So there's some more elements that aren't on this one, but this is good enough for what we're doing here. Anyway, those are atoms. So you got hydrogen atoms, helium atoms, oxygen atoms, carbon atoms. Those atoms then, we put them together and make molecules. So water, for example, is an oxygen atom and 2 hydrogen atoms. And you put those 3 atoms together and that makes a water molecule. So you got atoms, molecules. Molecules then can make organelles, organs, and that E L, at the end, E-L-L-S, organelles. It means little. So organelle means little organs. So cells have, the next is gonna be cells, so I don't remember there, so cells. You put a bunch of organelles together and then that'll make up cells. And all living organisms have a minimum of one cell. All living organisms have a minimum of one cell. And we have atoms, molecules, organelles, cells. All living organisms have a minimum of one cell. So let's look at cell for just a minute. I'm going to kind of do a subcategory here. Cells have three things. First thing is all cells have a minimum of three things. Now most cells have more than just these three. This is the minimum. You gotta have these three things to be a cell. Minimum. And the first one of those three is a plasma membrane. Plasma membrane. All cells have a plasma membrane. And plasma membrane, generally, loosely, we can say is like a skin. You know, things have a skin. You know, an apple has a skin. You have a skin. Your organs sort of have a skin. You know, that loose, general, broad skin. So it's like the skin of the cell is the plasma membrane. And skins are going to keep what's inside, and what's outside. So you have your skin. It's actually an organ. Your skin is an organ. But it keeps your water inside. You're not getting dehydrated like an octopus. If you throw an octopus out on the land, it's just going to all get dried up, right? A jellyfish, it's all going to just dry up. Because they live in the water, so they stay hydrated because they live in the water. All right, you got a plasma membrane. You got a cell, a skin that keeps you from getting dehydrated. So plasma membrane separates the inside of the cell from the environment that it's in. Cells have, number two, all cells have DNA. Bacteria have DNA. Bacteria have a plasma membrane. Fungi have cells. They have plasma membranes. They have DNA. Plants have DNA. Produce have DNA. Fish, everybody's got DNA. DNA is like your blueprint to make who you are. But actually, DNA codes for how to make a protein. And so all cells also have ribosomes. Ribosomes are a protein manufacturing plant. If you got a blueprint for how to make a widget, you got to have a manufacturing plant to manufacture those widgets, right? Else you just got some lines on a piece of paper. So DNA, now we always say DNA is like the recipe for how to make you, but actually DNA really only codes for how to make proteins. Proteins then go on to make the rest of you. So you use proteins to make carbohydrates. You use proteins to make nucleic acids. DNA is a nucleic acid. So you use proteins to manufacture DNA. You use proteins to manufacture and store and utilize energy, fat. Fat is a storage form of energy. And you need proteins to manufacture those. So your DNA codes for how to make proteins. Proteins then go on to do everything else. So DNA codes for how to make a protein, then you've got to have a manufacturing plant to manufacture those proteins. Now we're going to learn more about ribosomes later on, but right now, just ribosomes are a protein manufacturing plant. Ribosomes manufacture protein. So the DNA is the blueprint for how to make the protein, and the ribosome is the manufacturing plant. And all cells have ribosomes. Bacteria have ribosomes. Bacteria have DNA, bacteria have plasma membranes. Plants have ribosomes, DNA, plasma membrane. Fungi have plasma membrane, DNA, and ribosomes. All cells have all three of these components. If you don't have all three of these components, then you're not a cell. And we said it's a minimum. All living organisms are a minimum of one cell. So bacteria are single-celled organisms. You, however, are a multi-celled organism. You got billions of cells. So each cell in your body has a plasma membrane, DNA, and ribosomes. So you've got billions of cells. What else? Look at the list, because I'll forget something. These cells then regulate. All cells are capable of regulation. You regulate an internal environment and maintain homeostasis. Okay, you regulate and maintain homeostasis. So you regulate a constant internal environment. You maintain a specific water balance, right? You get too dehydrated, you get thirsty, so you drink water. So you're maintaining a constant water level in your body. Body temperature. What's normal body temperature for a human? 98.6, give or take a point or two. It can vary a little bit. Everybody in this room does not measure exactly 98.6 all the time. It fluctuates, but very little, very narrow range. If you've listened outside, you've heard spring peepers the last couple of weeks. What's a spring peeper? Well, they're little frogs. They're about this big and they're dark gray in color, about an inch long, little frogs. And they start calling, laying eggs in the springtime. So you hear them peeping. They make a high-pitched little peeping sound in the spring, thus the name spring peepers. And you can hear them calling now. And it was what? My husband and I sit on the back porch last night. It's like 50 degrees. Frogs, being amphibians, don't maintain a constant internal temperature like you and I do. They rather depend on the environment to maintain their body temperature. So the spring peepers out calling yesterday had a body temperature of around about 50 degrees because it was about 50 degrees outside. And that's a normal body temperature. But they can also be drop down to like 40 degrees and as much as like 60, 70 degrees. So they have a very broad range in body temperature that is normal body temperature range for those frogs. So range, that maintaining that constant internal environment, maintaining that homeostasis is going to depend on what species. If you're a plant, if you're a fungus, if you're a frog, if you're a fish, if you're a mammal. But there's a specific range for your species that you're going to maintain. pH. You maintain a blood pH level of about 7.3 is a normal blood pH. And you've got some proteins that regulate that and keep that very constant, very narrow range in that pH. If you get too far off of that pH range on your blood, it can kill you. So your body's very, very tuned and maintains a very, very narrow pH range in your bloodstream. It only fluctuates by like a point or two one way or the other. So homeostasis. Homeo is same, stasis is state. So homeostasis means steady state, a constant steady state. Living organisms regulate their bodies such that they maintain homeostasis, a constant internal environment that's different than the external environment. It's different than the external environment. You have to work to maintain it. Now, how are you going to work to maintain a constant internal environment that's different than the external environment? You're going to have to obtain and use energy. You obtain and use energy. You ingest food. That's where you get your energy sources, food that you ingest. Now, if you're a plant, you're out here in the sunshine doing photosynthesis. So you're converting solar energy into chemical energy and storing that as glucose. But you're not a plant. Now, if we took chloroplasts out of plants and put them in human skin, they would all be green and we could all do photosynthesis and it would save a lot on world hunger problems. That would be really cool. Why do we not have green people in our science fiction movies? I want to see green people in science fiction movies that have to do photosynthesis. That would be cool. All right, so living organisms obtain and use energy. And you maintain, your bloodstream, part of regulation too, is you maintain a constant sugar level, glucose level in your bloodstream. And if you didn't eat lunch and you get that, and you go get a Coke or something, a snack, sweet snack, you're bringing that blood sugar level back up. But your liver can store a little glucose. It's called glycogen when it's stored in your liver. And when your blood glucose level starts to drop, your liver monitors that in your bloodstream, and your liver's like, oh wait, blood glucose levels are too low, so your liver starts breaking down glycogen and releasing glucose molecules into your bloodstream. So you maintain homeostasis. Regulate an internal environment, maintain homeostasis, and you do that by obtaining and using energy. Living organisms, I'm running out of space. I'm gonna erase. I just erase that because I need space. What was that? Oh, growth. You also use energy for growth and development. Now, a brand new little puppy that's just a few hours old, a few days old, doesn't look like an adult dog. His eyes are closed, his ears are closed. They're soft and cuddly, and they're just everybody just loves so sweet puppies. Okay, maybe you don't know a dog person. Puppies just make me swim. But puppies don't look like adult dogs. There's a development. Human babies don't look like adults. Body proportion, face proportion, and all, it's all out of whack, right? For babies. Proportion to human. So, living organisms grow, they increase in size, and they develop. Even bacteria. Now, bacteria are single-celled organisms, so there's not a lot of development, but they do grow. And we don't think about bacteria as growing and developing, but bacteria, they divide by mitosis. They divide in half. So a bacteria cell is a large cell, and actually bacteria are teeny tiny cells, but the mature bacteria is large compared to the, so a large bacteria cell divides in half. It cuts itself in half, so it makes two cells that are half the size of the parent cell, right? Take one big cell and you cut it in half, you got two small cells that are half the size. Well, those two smaller cells are going to increase in size, they're gonna grow, but they're not gonna develop a lot. There's not a lot of change in development like you see between a puppy and an adult dog. Between a seed, you get a little seedling, you plant a little seedling, a little tomato plant, a little oak tree, and this tiny little soft green sprout comes up, and it gets bigger and more mature. It changes as it grows, it develops. You don't get that much development, that much change in bacteria, but they do increase in size. So growth and development, living organisms grow and development, and they reproduce. And they reproduce like kind. Yeah. Well, whales have baby whales, giraffes have baby giraffes, dogs have puppies, cats have kittens, humans have babies. Oak trees produce acorns which grow into oak trees. Fungi produce spores that grow into fungi. Giraffes don't have puppies. Oak trees produce acorns. Acorns don't grow into tulips. Right? It's based in DNA. So you've inherited your DNA from your ancestors, right? So have those oak trees. So is that grass out here in the yard. All these trees and all this grass out in the yard inherited their DNA from their ancestors. These two little bacteria. We have one big bacteria, we divide it in half. Those two new bacteria inherited their DNA from their ancestors. So organisms reproduce like kind because they pass on their DNA to their offspring, and that DNA was inherited from their ancestors. So, reproduce like kind. Living organisms also respond to the environment. Living organisms respond to their environment. You ever seen houseplants are sitting in the house and they're leaning toward the window? They're all kind of lopsided, leaning toward the window, and then you spin them around because they're getting all lopsided, and then in a few days you come around and they're like leaning back toward the window again. Or if you're really pay a lot of attention, there are people that turn their house plants just a little bit every day, or every few days they turn them to keep them even and fluffy all the way around, so they're not all growing lopsided. Well, that's a response to the environment. They're just bending their leaves to maximize sunlight, because indoors it's not as much sunshine as there is outside. So they're trying to maximize the amount of sunshine they're getting, so they can maximize the amount of energy that they're converting from solar energy to chemical energy. Now, down in Florida, there's an opposite problem, because it's flat, but there's a lot of sand, and that sand is white, and white reflects a lot of sunlight. And so plants in Florida, there are a lot of plants that want to minimize their exposure to sunlight. They're getting too much sun, and it's going to dry them out. And so rather than having leaves that are flat and that are turned toward the sun, they have leaves, their leaves, they'll turn their leaves so that they're perpendicular to the ground, so that they're minimizing the amount of sunlight that those leaves, that's hitting those leaves. So they're getting enough sunlight what's reflected around them. And it's helping them maintain water, because water will evaporate out of the leaves, and sunshine will make water evaporate faster. Another response plants have is during droughts. We have around here oak trees. During August, when there's a drought, the leaves will fall off the oak trees. because water evaporates out of the leaves, and if you're in a drought and you've got water evaporating out of the leaves, you just drop your leaves off, then you're losing less water to evaporation. So oak trees during a drought, like we have in August a lot of years, in the summertime, can drop their leaves. And I've heard people, oh no, the oak tree died during the drought, I gotta go cut it down before it falls on the house. It's like, it's not dead, just dropped its leaves, it's fine, leave it alone. Besides that, it's gonna take years for that tree to rot to the point where it's gonna fall down anyway. I mean, your house is made out of wood, right? The lumber in your house, that's a dead tree. How long is your house standing there? It's a long time. So anyway, trees will drop, some oak trees will drop their leaves in response to a drought. So if you see your oak tree in a drought and it's dropped its leaves, don't panic, it's not dead, it's fine. In September, when it starts raining again, the leaves will come back. If not in September, wait till the spring and you'll see it leaf out and look beautiful in the spring. My dad's got one oak tree in particular in their backyard that it tends to drop its leaves just about every summer. During August, it doesn't take, it's very sensitive. All the trees around it'll be full and green and have lots of leaves on it, but that one will drop its leaves during August just about every year. But it's fine, it's been growing like that for 30, 40 years. So that's the way plants respond to the environment. A bacteria may respond to the environment. There may be a pH or a water temperature, or too much sunlight, or it's getting too dry, and a bacteria will swim through the water, will move to a new location. That's response to the environment. It's kind of like lizards. Y'all, do lizards sit on the fence in the sunshine in the summertime to absorb the warmth from the sun? Because the lizard's temperature, and this body temperature can fluctuate a lot more than yours can. So they come out on the limb in the sunshine to get warm, increase their body temperature, and then they get too hot, and so they move off into the shade. So they're responding to the environment by moving into the sun, out of the sun. What do you do when you get hot? Take your coat off, you start fanning, you move into the shade, you turn the air conditioner up, turn the heat down. Saturday I was out tooling around doing stuff. I live in Alabama. We got out early in the morning, I had the heat on in the car, and by about 2 o'clock that afternoon, I was like, 9 o'clock, and I turned the air conditioner on down. So you respond to the environment. You actually have the capability, that's one of the things that humans have that other animals don't have, to the extent that we have, is the ability to change the environment to suit us. We build buildings and then we turn the heat and the air conditioner on, and we maintain the temperature and humidity in the house inside the building that we like. Plants and animals can't do that. Squirrels can make nests, but they don't. They can't regulate them the way we can. So we respond to the environment. Now that environment is not just what's around us. Your cells. You got billions of cells, right? So your body's like your own little ecosystem, and those billions of cells that make up your body is their environment. Your bloodstream is the environment for those cells. So your cells respond to the environment that's around them. We said your liver monitors your bloodstream. When your blood sugar level drops too low, your liver says, hey, there's not enough glucose, and it dumps glucose into your bloodstream because your cells, each individual cell in your body needs glucose, because that's the energy source for that cell. And that cell is like a machine. It's got to have energy. It's like your cell phone. When your cell phone goes dead, your battery's down on your cell phone's not broken. All the components are still there. It just doesn't have energy. It's got to have energy to function. Your cells are the same way. They've got to have energy to function. And so your liver monitors your bloodstream and keeps an adequate amount of glucose in your bloodstream so that each individual cell in your body has an adequate amount of glucose. When you get thirsty, your cells are getting dehydrated, and your cells are starting to send a signal that goes to your brain, and your brain interprets that as, hey, there's not enough water in this environment, and your brain tells you that you're thirsty, and so you want to go and drink water to rehydrate yourself so that your cells have enough water. And if you're thirsty, don't drink caffeine, because caffeine is a diuretic. And what diuretic means is that's a molecule that tells your kidney, hey, get rid of excess water. Because your kidneys monitor the water level in your body. Y'all know, if you haven't had anything to drink all day, you're not gonna go pee, right? There's no urine, man. If you're dehydrated, you're not peeing. If you drink a lot of water, you're gonna go pee a lot. Your kidneys are monitoring the amount of water that's in your bloodstream. And if you get too much water, your kidneys will get rid of the excess water. If you're dehydrated, your kidneys don't, and they keep water in your bloodstream. So that's a way that your body responds to the environment. Your individual cells respond to the environment that they're in. They're in your body. They respond. Alcohol also is a diuretic. So you're out drinking with your buddies and everybody's got to go pee. That's why alcohol is a diuretic. It tells your kidneys flush out excess water. And then if you drink too much, the next day you get a hangover, you get a headache. A lot of that headache is you're dehydrated. So don't get dehydrated and don't drink too much. Because you drink too much, then you do stupid stuff. And y'all aren't stupid, because if you were stupid, you wouldn't be here. So don't do stupid stuff. Don't drink too much. That's about where I got with the other class. We ran over a few minutes with them, but so living organisms respond to the environment. Can you study living organisms without studying the environment that they're found in? No, you have to know about the environment. If you're thinking about plants, even house plants, you put house plants in potting soil, right? Orchids are plants, but orchids are what we call epiphytes. They live in the tops of trees. Their roots are what we call air roots. You don't put orchids in potting soil. It will kill orchids. You put some loose bark and you water it, but you let the water drain out and let it get completely dry before you water it again. African violets are the opposite. They want, and shamrocks. These are woodland plants. They live in the woods, in the deep shade in the woods, so they like to stay cool, and they like to be fairly moist most of the time. You want them to dry out, but not like a cactus. So, environment for plants is going to include soil. And there's different kinds of soil. A very sandy soil drains water very fast. A very clayey soil will hold water. So in Florida, in the coastal plain, very sandy soil. So we'll get about the same rainfall in Florida as we do here, but we have more clay in the soil here. So our soil holds water. In Florida, the water drains out so fast because it's very sandy soil. So plants in those areas tend to have water retaining properties, kind of like desert plants. They can absorb and capture and store water like desert plants because they get a lot of rain, but it washes right out of the soil. Here we have plants here around here in Alabama that they don't necessarily store a lot of water because we get enough rain that they just depend on the rain for their water. So water is a component, rain is a component of the environment. dirt, soil is a component of the environment. What's the composition of the soil? That's part of the environment. So you gotta know what the soil is. You gotta know how much rainfall there is if you're gonna study plants. You wanna look at what's going on at cellular level in a plant, you still have to know something about the dirt that the roots are in. So you have to know about the environment. So the environment is part of biology. Ecology is the study of the environment. So when you the word biology, studying living organisms, is a very, very broad term, very broad. That's about it for today. We'll see y'all on Wednesday. No lab this week. Start lab next week.
Camera stop record.